we're going to discuss the Java compilation process. We'll talk a little bit about compilation in general, and then we'll talk about what makes Java unique and why it's become popular, and also why people are starting to move away from Java in some cases. Let's talk a little bit about this program that we had written before. Let's say it's just this one-liner, system out, println, hello, like that. And let's say that I ran the compiler on my machine over there, and it produced this sequence of digits like that. And let's say that this happened to be from some other language other than Java. Okay, so let's say it's not Java. Let's say it's some other language that's similar, but not Java. And so it ran the compiling process. It ran this, and I ran it on my machine, and it sure enough printed the word hello on this screen. So it worked perfectly. Now I have a question for you. If I was to take this file here, right, take this file and send it over to your computer, and let's say your computer happens to be a Mac, okay, made by Apple, right? And let's say you try to run this file. Do you think that the word hello will appear on the Mac? What do you think? What do you think? Sir, tell me your name again. Kevin. What do you think, Kevin? Yeah. Okay, tell me why, Kevin.
Because Macs are like Java-based.
So any computer, Kevin, can run as long as the right set of instructions are there. The Java is at this level. At this level, the machine code, it doesn't know what language it came from anymore. But there's another reason why this machine code will not run on the Mac. Can anyone guess why? Yes, Ms. Nuha? It does use a different compiler, and the reason it uses a different compiler has to do with the fact that the company that made the CPU chip is a different company than the company that made the CPU chip in my Windows machine. So let's say here's my Windows machine, right? And here's my Mac, or your Mac. And you notice they look remarkably similar. But this machine, if you were to open up the back, there's going to be a big flat green board on it. It's got black chips on it. And there's one chip in particular that's much larger than the other ones. And when you run the computer, that chip runs really, really hot. What chip is that? It's one giant chip on the motherboard. Yes, sir. Tell me your name again.
Brian.
Brian, what chip is that, Brian?
CPU.
It's the CPU. So the CPU chip here is made, if this is a Windows machine, it's probably made by one of two companies. Anybody know the names of those companies that make that chip? Yes, sir.
Intel?
Intel is one, and AMD is the other, Advanced Micro Devices. They make this computer chip, and it has a certain set of ones and zeros it needs to print the word hello. Who makes the Apple chip? Now, for many years, Apple used to use a company called Motorola to make their CPU chips. Who makes their CPU chips now? Anybody know? Apple makes their own CPU chips now, okay? Because this is a large chunk of the value add, so they want more of the profits. So they've integrated their own CPU chips into the system. And so these are made only by Apple, as far as I know. And Apple can also print the word hello, but their sequence of ones and zeros is a different sequence of ones and zeros because their CPU chip works differently than the CPU chips for the Windows machines. You see that, right? So let's say I wrote this program, right, and it produced this machine code. If I want to run this program on the Apple machine, what would I have to do? Yes, sir.
You'd have to compile it on the...
You'd have to take the source code. So this is the source code. And this is the machine code. Right? You'd have to ship the source code over somehow. Maybe you email it over to your friend's machine here. And then you would have to recompile it using the compiler that's on that machine, because that compiler knows the ones and zeros that this machine wants, right? And it would recompile it to a different set of ones and zeros, maybe like that. I don't know, right? And then the Apple machine would be able to print out the word hello also. So it turns out that almost all the compilers that are out there today use this process, but not Java. Java introduces an additional step into this process, and we're going to talk about that now. In Java, the compiler does not produce machine code. It does produce binary, okay, produces some binary sequence. But this machine, the code that it produces is called bytecode. Like that. And when bytecode runs on a machine, let's say I ran it on my Windows machine, the CPU does not know what to do with bytecode. It doesn't know. It's like, what is this? This makes no sense to me. What happens when you run it is that another piece of software comes along called the Java Virtual Machine, the JVM, the Java Virtual Machine. And each time the computer needs an instruction, it takes the bytecode and it converts the bytecode into machine code and feeds the machine code to the CPU. See the difference? So when you compile, it takes the source code and turns it into bytecode. And then when you run it, the Java Virtual Machine helps the CPU by translating the bytecode into machine code. Why do you think there is an advantage to using this bytecode as an intermediary? Something in the middle. Ms. Nuha, what do you think? The CPU doesn't produce machine code, miss. The CPU just runs the machine code. There's an advantage to having this bytecode. Can anyone guess what it is? This bytecode runs on any machine. It runs on this machine. It runs on this machine. It runs on the computer that's on my wristwatch. It runs on your phone. So I can take a program like this, compile it once, produce the bytecode, and I can ship this bytecode anywhere to any machine and run it, and the Java Virtual Machine that's on that machine will know how to translate this bytecode into whatever machine code depending on whatever computer I'm on. Do you see how powerful that is? You can write the program once, compile it only once, and then take this compiled bytecode and send it to any machine in the world. It could be an IBM mainframe. It could be that toaster oven right there. It doesn't matter. As long as there's a Java Virtual Machine on it to translate the bytecode to machine code, you're good to go. And that is the single biggest advantage that Java has over the other programming languages, is that you write it once, you can run it anywhere. But strangely, over the last few years, people have started to move away from Java. And it turns out it's because of this. Because Java's biggest strength is also its biggest weakness. What do you think is the danger of the bytecode? Think about the world that we live in now and what's happening. And what is the disadvantage of writing a program once and being able to send it anywhere and have it run? What do you think? Mr. Owen, what do you think, sir? Can you think of a disadvantage?
Viruses can be like dispatched on a large scale.
This is the hacker's favorite language. They just write the virus once, and then they create the machine code, and then they can ship it off, and no matter, they email it to you, you accidentally press the wrong button, right? You say, oh, yeah, okay, I know I won that money from that prince in Nigeria, right? And you click the button, and boom, the bytecode goes into your machine, it starts to run, and they don't care if you're on a Mac or a Windows machine or Linux or whatever. You see the disadvantage? So this flexibility of having one piece of bytecode that can run anywhere is also sort of the biggest risk for Java. And so some developers are moving away from Java to other languages where they don't want it to be so flexible. They want to force you to recompile the program on every different computer. Okay, so that is the compilation process for Java.